So I called it Agile data science because we need to be quick. And the work that I'm going to present, basically, yes, I sort of wrapped them up in 15 or so slides, I think not more than 15, thinking that this was going to take actually 15 minutes or 20 minutes. Right? Anyway, so, and the work I'm going to tell you, or the kinds of things that I'm going to tell you, is basically a result of 3 or 4 years that we have actually put into at my university. It's a new university. You can see it as a startup university. And I have been actually involved in many, many aspects, including how it actually led up to data science. So my initial slide, and I'm always kind of wary of the first slides, it has to be sort of an icebreaker, but this may also make new ice, right? So I'm just hoping it's not like that. Anyway, so when I was a student, this was in 1994, I remember how web was. It was usually static HTML being actually put out there by some certain people, and we were consuming that information. That's how it was. This was in 1994 when I actually got into an undergraduate program. In 21st century now, everybody is being an author, right? And we are contributing to this, to the web. And it is evolving, and everybody is contributing to it. And you may see different, everybody has an opinion. I have an opinion too, but so Web 3.0, from some of the things that I see, looks like machines really getting in there, kind of understanding and generating. This is, I think, the understanding and generating is actually the sort of the key things, like also, like human beings do, and also consuming information. Okay, so there's a lot of data. We've been thinking about, talking about, there's so much data around. And we are saying skills are required. And from my perspective, I want these skills from my, for example, at my school, from the undergraduates that are in the computer science program. I want them to have data analysis skills. I want them to be creative for generating ideas, for new ideas, and also hypothesis testing. So believe me or not, when I actually go and present in different places, I ask people, can you describe me what actually an A/B test is, or a controlled test group, a control group testing is? And I am kind of surprised. People are not actually giving me the exact sort of description, even though they are saying, oh, of course everybody knows it. Everybody knows by heart what an A/B test is. But if I tell them, okay, tell me what it is, and they really have a hard time telling me what it is. And I know from my industrial experience, Google is using A/B testing. Everybody is using A/B testing. It is fundamental. But we are missing the fundamentals usually when we try to tell, okay, we need to do complicated stuff. But if you don't understand the fundamentals, how are you going to do that complicated stuff? So, and we are saying, or I am sort of proposing, we need to tell this, or we need to sort of impose this on the undergraduates, but we also let the K-12, the high school, also know, high school, let's say, program generators or program managers, know that this is what we want from the students. If you also put these things in your own curriculum or programs, it is much better because this is what we're going to do. This is what we're going to need. If you're prepared, everybody's going to be more prepared. And sort of, we are hoping that this skill need pressure that I'm sort of talking about here is going to sort of percolate down to the high school and maybe from there on even earlier. So this is from IBM Developer Works Tech Trends study. This was done in November 2012. And the study is saying or highlighting that roughly a quarter of enterprises are saying we have a skills gap in these major technologies that are sort of coming up, right? Mobile computing, cloud computing, social business, and business analytics. And these are the sort of four main technology areas that IBM is trying to sort of pioneer. Or it has been actually been a pioneer and also want to sort of drive the evolution. And the study is saying there's a skills gap. So in a way, I kind of put this picture out here. That's the industry, and they need a skills need, which looks like a circular shape. And what we are sort of teaching in the academia, that doesn't quite fit. And IBM wants it, a more circular shape so that, it can fit it, right? So what is our solution? So I'm representing my university here, of course. And our solution is we designed the curriculum, basically, I spent 10 years in the States, 2000 to 2010. I got my PhD here. I worked in 2 different companies, one Citrix, the other one like.com, was in the Valley, and it got acquired by Google, and I moved to Turkey after the acquisition. And the faculty in Istanbul, Sehir, is people like me, actually. The faculty members are like me. They got their PhDs in here in the US, and they have work experience, people from NVIDIA, people from Qualcomm down in San Diego, and from IBM, basic IBM research. We have a lot of people, very skilled people, and we asked, we just sat on a table and we said, what was the thing that you really sort of suffered the most when you were trying to do things in the industry? Just think about what has been taught to you at school, and think about what you needed the most when you were trying to solve things, or problems, or trying to implement things, right, or research problems. And we understood that, basically, we had to say, from now on, we're going to say no to a class which is called programming languages. This is what we understood. And everybody said, OK. And what are we going to say yes to? An example systems class. A general systems class where we teach the students, basically, for example, here is an example. We're going to teach students in the systems class how to run a web application on top of a database that may be distributed. And I'm going to tell them it's distributed because there may be a lot of load, basically, a lot of users using this application, and it better be distributed, behind the scenes to handle the load. It's basically, the idea is to expose the students, early on. This is what is happening. This is what is, what the industry needs, and drop them in the ocean, basically. Instead of, having this sandbox environment where asking them to do projects that very isolated here and there, and they don't grasp the big picture, I think, which is the fundamental flaw in the way that we teach. So when we were designing the curriculum, we had a few design principles, key design principles. The first one was leave little room for bloating the curriculum with unnecessary classes, and I gave you an example. Because time is of the essence, and we can't just beat around the bush. We need time. And we need to abridge the gap between undergraduate and graduate programs. I have, for example, my current course load in Istanbul Sehir University. I am teaching a master's class, which is called data engineering / maybe science, and an undergraduate class, which is software. Not software engineering, software. So we're just keeping things a little light, when even we call our classes. Systems, software. I'm actually going to mention the classes, basically. But I'm thinking, if I'm going to teach these students something different in the undergraduate level and in the graduate level, I need to do a context switch. And that is costly. For me to keep track of what I'm going to be doing in terms of research versus what I'm going to be teaching, they should be in alignment. They should be in orchestration. Otherwise, I'm going to be doing unnecessary work or something that doesn't actually quite rhyme in the big picture. So we decided they need to sort of be sort of interacting. The classes should be interacting. They shouldn't be discrete, but there should be a continuous sort of exchange. And the third one, this has to be this. So if someone tells me, how do you sort of see, how do you measure, for example, if you are successful? I would say, if my students or if our students are engaged, they are sort of excited, if I keep that excitement level intact, that is what means, then I can say, yes, I was successful. So this is our sort of core goal, where we're going to pick a programming language for instruction that is versatile and agile. As I said, everything is sort of geared for gaining time. And we need, because it's a computer science program, of course, we're teaching a programming language. And you may actually guess what that programming language is. OK, so these were these three sort of design principles were sort of theoretical, and we did apply them, and this is the results. Our core classes in the third year look like this. We have 6 core classes: algorithms, systems, so actually algorithms is 1 and 2, systems, architecture, machine intelligence, and software. So these are the 6 core classes where we sort of really heavy on, we put a lot of sort of emphasis on actually teaching the students these core areas. The second design principle, the abridging the graduate and undergraduate program. Well, I am teaching data engineering in the last semester in spring 2013. I also taught a class called programming practice. This was a second-year class, actually sophomore level class. And what I did was I diluted the data engineering class, basically, for programming practice. The same concepts, the same applications, but a little less theoretical, basically. But the same thing, the same applications. And the third, we chose Python. I am a big sort of driver behind, actually, I get a lot of sort of, resistance and pressure, basically, because they say, everybody is using Java. Well, everybody's, for example, all the other schools in Turkey, they are using Java, they are using, I don't know, .NET framework. Why are we going with Python? I get that a lot from students. I get that a lot from my peers. But believe me, everybody's kind of moving towards, actually, to what we have. And I kind of know, because coming from industry, using Java maybe 10 years, why shouldn't I actually teach them Java, right? I have all the kind of purpose actually to teach them Java, but I don't. Because I know I need a language which is kind of agile enough and sort of easy to pick, so that they can get, I can sort of keep them engaged at all times. Remember, keeping them engaged means now they're going to devote more time and work if they can get engaged. But if I'm going to sort of tire them with sort of heavy stuff, then they won't. Okay, and these are the fruits. So this is, again, from a sophomore year class. These are the term final projects. And if you look at them, it's basically, for example, they're using collaborative filtering on Netflix dataset. This was a student project. These are second-year students, remember. News filter, they are using classification. I taught them how to do naive-based classification. I taught them what classification is. I also taught them, it's very mathematical. Naive-based classification is probability and mathematics. So it's quite actually easy to grasp. But the whole idea is to classify. And also TweetPy. We have a lot, actually. I just sort of gave you 3 here. But the applications or the kinds of things they did actually also amazed me in a way. So what is the future for us? Again, when I look at what we did in the last 3, 4 years, I see that this was kind of the road was leading up to this, in a way. A data science, basically, graduate program, again, pushing all the things or the skills need down into the undergraduate and then on to the high school level. So basically, we're working with IBM Turkey on this, sort of a joint data science graduate program. And these are the classes that we have in the program. And these are not actually, we should have these classes, but these are really the classes that we are teaching, basically. I'm teaching the data engineering class. I taught the second class as well, networks. And all my other peers are basically teaching these classes. And let's sort of go through them a little. For example, we are teaching them how to, data visualization is very important. Again, it's a very pivotal role because they need to visualize data to really, oh, I see something interesting here, right? Then they can get sort of, they get motivated and they can put more time. Scalable systems, big data analysis. These are, again, with the help of IBM and IBM tools, we're going to be actually helping them work on big data. Probabilistical graphical networks, these are very sort of important classes, basically, where we teach them how to do probabilistic inference. Machine learning. And also those 2 classes, basically the 8 and 9, again came out of the whole that sort of brainstorming with my peers, what you really needed the most when you were in the industry or when you were doing PhD. And we realized optimization and understanding how systems work in linear space, basically, and modeling it in linear sort of, in state space basically meant a lot. And I think that's my last slide, so thank you.